Science Summit. This is our last workshop hosted by our co-host Taipei Tech. I'm going to pass it over to Freya for her to introduce the workshop for us.
Okay, thank you. Good morning, good afternoon, good evening, wherever you are. Welcome to our workshop. System within system. It is going to be hosted in Taipei Tech. Okay, next. Apparently I cannot see it. Okay, so first of all, I will give you a brief introduction for today's theme, and after based on this theme, we are going to break up into two sections. One is autonomous delivery system. The other one will be thermal environments within a sustainable subtropical city. So, and after those two sessions will be held in parallel, and then we'll have a breakout discussion. The first session will be broken out into three groups, and the second session will be broken out into five groups. And then at 10 after 8 p.m. in Taipei time, we will have every group to present their conclusion. Okay, and then every group will have 2 minutes. Okay, next. Okay, my name is Leehter Yao. I'm also the director of City Science Lab at Taipei Tech. Next. Okay, so the theme in our workshop is system within system. So let's see what is that. Next. So you can imagine this. Within the city, there are several different systems, and within each of the systems in the city, there will be different subsystems. Okay? So our workshop today will be focusing on, can we design those subsystems for the system within the city? Okay? So this is our idea. And so a very famous environmental scientist, Leehter Yao, he once said that system can exist within system, and that successful interconnected system keep an overall system purpose and subsystem purpose in harmony, right? So the system within the system, we are sure that the density will be kept in harmony so that the city can run very well. Next one. So within the city, there is a system. We call it the delivery system. And so we are going to design an autonomous delivery system within that system. And later on in session 2, we'll go up to the previous page. Later on in session 2, Professor Huang is going to introduce you another system that is, well, we can roughly call it the information system. That system is going to provide integrated information for thermal analysis. Next one. Okay, so in our session, in the first session, okay, so we will talk about autonomous delivery system within the city. Next one. After my presentation, give you a brief introduction of this session. We are very happy to have three welcome professors in Taipei Tech to help us host the group discussion. The first professor is Professor Zhuang. He is from Department of Mechanical Engineering in our university. And the second one is Professor Lin. He is from our Graduate Institute of Automation Technology. And the third one is another Professor Lin. He is also from Graduate Institute of Automation Technology. So as you can see, three experts in automation are going to be the mentor of our three session groups. So we will talk about, because we are going to, in this session, we are going to talk about the autonomous delivery system. The autonomous delivery system, well, I think most of you will be familiar with that, especially when we have pandemic all over the world. So we have to buy anything we want. We have to buy food, buy clothes, buy sanitary products. So we don't have to really go to the shop. We ask Uber. What we have another dependent. Well, so we currently we have different kind of delivery system to deliver whatever you want for you, especially during the pandemic difficulty. So is it possible? Is it possible? We don't have to ask human being to deliver those objects for us. Can we design an autonomous delivery system? Within this autonomous delivery system, there are several agents. I call it robots. Those robots can deliver things for us. Or one, we use a lot of e-scooter. So can those if those e-scooter require charging, can we ask those charging robots to charge our e-scooters? Of course, can also charge all our electric vehicles. So this is what we are going to discuss. Okay, so yeah, as you can see, we have for this system within this system, we might have a scenario or location. So the location might be a hospital or campus or supermarket, and then we will have a subsystem within a system. So the subsystem might be our maybe our delivery subsystem within a larger system, and then we also have those robots playing as an agent doing specific tasks for us. Next one. So I'm going to introduce you the e-scooter charging system. So we have 23.5 million people in Taiwan. You know how many motorcycles we have? We have 14 million motorcycles in Taiwan. So almost two people can have one motorcycle. So we have a lot of motorcycles because Taiwan is a very densely populated island. So the space is very limited. So it is more convenient to use a motorcycle. So according to our government's regulation, by the year of 2030, we will forbid the gasoline motorcycle. Everyone is required to use e-scooter or e-motorcycle, electric motorcycle. So we still have 5 years to go. So within this period of time, we might see in the parking lot, we might see there are some gasoline motorcycle and some electric motorcycle. So is it possible we could fulfill the charging for those e-scooters? At the same time, those e-scooters can still park the regular parking lots. Okay. So as you can see here, within this is the additional parking lots. Suppose we have some of them are e-scooter, some of them are gasoline motorcycle. Now, is it possible we don't have to build a charging system, electric charging system? But if e-scooter has a request to charge their e-scooter, they can just scan the QR code on the ground, so that the charging robot will automatically know, oh, the e-scooter parks at this spot. This e-scooter has the demand to be charged. So the charging robot will automatically go to that specific spot and charge the e-scooter automatically. Okay, this is what we are going to do. So this is the prototype of our charging robot. Actually, it is here. See, this is the prototype of charging robot. So well, there are different kind of gadgets. So you can just take a look at it. Next one, next page. So I'm going to show you within those gadgets on the robots. This robot is automatically doing obstacle avoidance first. As you can see, let's take a look at the first video. This video, if this robot detects that there is a coming object that is moving faster than this robot will pull over automatically. And then give the space to the fast-moving objects. Okay? And the second video here, if this robot detects that there is a object moving slower than this robot will overtake this object. Okay, so that this robot is, can avoid the obstacle smartly. Next one. And the most important tactic is the robot to, plug the charging port into the socket. Okay, so we have a camera and we have some kind of automatic positioning system to plug the charging port into the socket and perform the charging. And after the charging is finished, this robot will take the space. Okay, so basically this is like this. Okay, next one. Station. And the other one I'm going to show you is the object delivery system. So this agent with this smaller system will do the autonomous delivery for us. So imagine this. On this canvas, actually we have made it. This called the canvas road. In Taipei Tech, we are going to design this kind of object delivery robot for us. If you have anything to deliver to anybody, you can use app to call this robot to your office, and then you just put the object you want to deliver into the drawer, okay? And then you send the QR code to the receiver. Then this robot is able to automatically go to that destination. In other words, this robot will provide door-to-door delivery service for us. Next one, because I have very limited time, so I probably have to jump into the video. So yeah, this video. So this robot is able to operate the elevator itself, and then get into the elevator. And then push, any floor this robot will go. And then when the elevator moves to the destination floor, this robot will also know the destination is there. And then go out automatically, of course. This one. Of course. Well, as you can see, we have many people, especially in university campus, right? So this robot also have to have very good obstacle avoidance capability and also object tracking capability, so that this robot can move smoothly on the campus. Okay, so this is about my introduction of both robots. My time is on, so I will hand my microphone to Professor Huang for next topic. Thank you for your attention.
Yao.
Professor Huang, King of College of Design, Taipei.
friends of Taipei, Taiwan. My pleasure today to introduce you our CSL team to share with you our focus issues in the past few years. Now, thermal environments within sustainable subtropical city. And these issues are solar radiation, thermal capacity of building temperature, deep storage of asphalt pavement, vapor transpiration, tumbling fields, and the vertical structure of urban heat island. CSL Taipei Tech is a research team with interdisciplinary integration is dynamics from urban design, architecture, building engineering, civil engineering, material science, and interaction design. By field measurement, big data analysis, Orion, information visualization model, intend to set up urban climate mapping 3D platform. Using the data from high altitude balloons, drones, and satellites, try to formulate heat transfer process urban area. We have explored various holdings for their effects on emission of storage building terminal. The influences the heat capacity, transmission of the facade, efficiency, air conditioning, ozone. Heat transfers and balance over load periods site. Climate scenario. The vertical grading measures make an impact on ecodynamics in the duration. By urban design measures, the motion of the Venturi effect, channel effect, remnant evaporation equation in the urban wind fields. Heat absorption, storage and emission, wall, asphalt paving of different coatings or aggregates. Based on these data, we simulate the thermal environment and related cooling material aspect of an area. And the results show that there was no difference from the air temperature at 9 a.m. Yet, 9 p.m., our air temperature was 12 degrees Celsius cooler than regular asphalt paving. The global wind field planning, declaration of planting, and reached 6 degrees Celsius. Without the help of the wind, active evaporation appears enthalpy, which leads to a rapid decrease of thermal comfort. Then we have applied the site planning, building design, and to promote an effective wind field. The CFD simulation shows the reached 4 degrees Celsius increase at some hotspots in the building design matrix. It provides more cool air or enthalpy. We can also try to analyze vertical structure in learning. Using data from calculated laws, we have tried to locate temperature inversion at the urban boundary layer.
Device 2 connected.
The results demonstrate that the height layer
Audio cut out on camera 301. We can no longer hear. Sorry, everyone. I know that there is some difficulties with the audio, but thank you guys for hanging in there with us. We're trying to work on it. We appreciate everybody's patience.
the cloudiness and the humidity following a law of the variation of urban boundary layer. Applying artificial intelligence and IoT technology, we shall adapt the cloud sensing method to collect thermal environment data in urban areas. We employed the color visualization method to present the space background recognition, visual closure, and spatiality of temperature data in 3D. We integrate the concept of heat island information model and space syntax to set a cloud information visualization mode, which presents a three-dimensional transformation of thermal environment. We are looking forward to having more discussion or even cooperation with you all. Thank you very much.
Thank you very much for the presentation.
Yeah, repeat again. Well, you can see the power of Murphy's law. Everything is ready. If you do not pay attention to a little thing, it will give you a disaster. So I'm sorry. I know that some of you might not hear very clearly about Professor Huang's excellent speech, but that's okay, because we are going to break up session 1 into 3 discussion groups, and Professor Huang's session will break up into 5 discussion groups. So for those people who are interested in how we integrate information within the city, please join session 2. And if you are interested in knowing more about our 2 little robots, please join our session 1. I will see you 1 hour later. We'll come back. Then we'll have excellent conclusion from every discussion group. Thank you.
While we get set up to report back from the breakout groups, just an FYI that the closing ceremony will be postponed by about 15 to 20 minutes to give some time to report back from the breakout groups. So if you would like to see the closing ceremony, please stay online with us even after the Taipei Tech workshop. And if anybody is joining just now to join the closing ceremony, we're going to be finishing up the workshop reporting, and then we will get started with the closing ceremony shortly afterwards. So please stay online with us. Thank you.
We're just brainstorming ideas for system within systems, and then we came up with about 5 different ideas. So idea 1 was about the idea of transitioning between modes of transportation, so sharing systems for modes of transportation, so we will decrease the vehicles that are out on the street and then using what we already have. And then idea number 2 was talking about the idea of autonomous vehicle agent or system, help transport people from A to B in an urban environment. And then number 3 will be allocating people on the streets, providing them an optimal route. So like an optimal GPS system in the city, so they can get to their destination a lot faster, and it will be different for each person. And then number 4 will be the idea of optimizing public vehicle routings. So then it's almost similar to number 3, but it's helping to decrease the waste of resources, both government and local, and then also at the same time decrease pollution. And then number 5 is more of a policy for the government, sort of to help incentivize people to use greener mobility. So that's basically the ideas we gather in the breakout session.
Well, thank you. Do you have any comments or questions? If so, then we can move forward to the next segment. So you guys could tell us what you talked about.
Okay, so thanks for Group 201B's presentation.
I think that the speaker might have frozen. We're back now, but we missed a little bit of what you said previously. Here for group 2. I can't hear you. I think you might be.
Okay, just okay, so in our group, we focus on airport. We create some auto guiding system, and in this system we have we create some a subsystem, and it's a auto guiding charging system. So imagine this. It is the if you have the car, you just go over where you can to. If you have the electric car, so it's the battery is the issue of all the electric car. So we create an auto guiding charger. So if you want to if you have the electric car, so you can to park everywhere you can charge your car. So in this auto guiding charging system, to have a parking space searching to combine the parking space searching device and auto charging device for the passenger. So the passenger can to leave their luggage on the car, and the car to charge their battery automatically.
Yeah, okay, many thanks for Group 201B for their sharing. And now let's welcome Group 201A to share their thoughts, please.
Oh, hello. Okay, so the main idea about the system within system is like another subsystem support one main system.
I'm sorry to interrupt. We can barely hear.
Summarize in general terms. The purpose is like the scenario can be in the
factories, like inside the factory, like polishing factory, can have some polishing machine, and by doing this, we can replace the human by machine, so the quality can be more stable. There is the polishing result, and also we can achieve more time saving, and we can get lower cost. So another scenario can in the gym maybe we can have the subsystem transportation system to transport the equipment like dumbbell and put it back to the original position. That's the subsystem of the gym system. And also we can have another system like the for managing system, managing to calculate how many people come out and how many time you spend now you occupy the machine. So it can be the subsystem of the inside the gym system. And also you have another idea like in the scenario can be a cook factory, and the subsystem can so that's the idea about the system within system. Thank you.
Okay, thank you, Group 201A, for your sharing about your ideas. And now let's move on to 301A, led by Professor Wu, to share their findings.
Oh, so we're the T302. We're going to talk about the urban heat of island effect. And we said that the Taipei city, the Taipei Bison, has urban heat effect of about 34 degrees and about 5 degrees warmer than the surrounding area, which causing a problem within the city. And thus we came up with two other solutions to this urban island effect, which is greening. Sorry. Okay, so by increase the greening. Okay. This. How about share? Just move it on. Okay. Okay, so if I increase the greening within the city, as you can see in this graph one, that within the city there is only about 10% FVC of fraction vegetarian coverage. By increasing the okay, so everyone see the PowerPoint? Okay.
PowerPoint looks good.
Okay, so we came up with some solutions to how to increase the greening within the city. First, we can increase the green roof, like by covering rooftops with green vegetarian coverage, and increase the road system with greening as well, based on increasing parks within the city. This should majorly increase the greening within the city that would mitigate the urban island effect within the city. And the second solution is to cremating the water within the city. By retaining water, it would cool down the city by retaining reducing the amount of area of human activity, which is seen in this graph on the right. You can see there's only 90% of area is human activity, with only 0 to 10% outside of the city. So by reducing the area of human activity, which is like parks or rivers, canals within the city, should effectively reduce the urban heat effect of the city. Okay, so we came up with these two solutions. Is there any other question? Okay, this is our team photo about the workshop. Thank you, everyone.
Okay, thanks for group 301B, and we appreciate your sharing. And now let's move on to 301C, led by Professor Zheng to share their findings.
Hello. I'm going to give a brief summary of our team's discussion. We discuss about three different ideas. First, we focus on how to use materials and mineral to elevate the urban heat island effect. We can discuss the concept of zebra strips that could be used to control their body temperature. By using reflective white coating and absorptive black coating on pavements, buildings, and a roof to create a turbulence to improve the urban heat island effect. Second, we discussed about passive house that we can set up low-heat windows, improve buildings' inner structure to create cross ventilation to cool down buildings' inner temperature. Last but not least, we talked about the possibility by using chemical to mitigate the urban heat island effect. To sum up, no matter which method we use, we believe that the principle is to choose the most suitable materials under different scenarios for solving the urban heat island effect. Thank you.
Okay, many thanks to group 301C. And now let's move back to group 301A, led by Professor Wu, to share their thoughts.
Share screen now.
Share screen.
While you guys are getting that set up, I do see that we have a few people that have joined us on the call. So to those of you that just joined us, if you're joining for the closing ceremony, that will be starting in roughly 10 minutes. So hang tight, we're just finishing up the workshop here and then the closing ceremony will start shortly.
Yeah, PowerPoint 传到另外一个。讲得很好。传到传到。
你的档案是在桌面吗？在桌面，放在桌面。
Okay, while 301A is dealing with the problems, I think we can first move to 302A for their presentation. Yeah, shall we? 302A.
这个很不现实哦。
应该是这个，可以。
这是麦克风。
加油！哎呀呀！
Hello everyone, we are group 302A. And first, the issue, we try to focus on the rooftop addition problem in Taipei at the beginning. And heat island impacts some people more than others, people with limited personal resource like income or mobility are more vulnerable and deserve more support. And first, many people in lower economic status in Taipei are living in the rooftop addition, most which are built with less costly materials and therefore very inefficient in terms of energy use. They have to spend more on the air conditioning and the heat generated by the air. And it also makes the heat island effect more severe. It becomes a vicious cycle. And second, similar patterns can be observed in the cities with lower density. People with lower incomes usually cannot afford grow trees in their yard. And this also leads to the heat problem. And by the way, the social housing rate in Taiwan is 0.8%. It's very low. And move on to the solution. First solution is social housing on the rooftop. And this idea try to deal with the two problems. One is heat equality and another one is right of housing, and try to deal with them at the same time. This project is designed by a Taiwanese team. This is a systematical green rooftop addition idea and trying to create a rooftop social housing with heat mitigation strategies. And the second solution is bioreactor wall on the facade. And this idea is used the algae to create a curtain wall to and absorb solar radiation and purify the air. And impact, first social impact is the housing justice, and second environmental impact. There are four impacts. One is beautification, two is energy efficiency and generation, and the third one is rainwater collection, and the fourth, urban farming. And wrap up. To echo the topic of today's workshop, system within system. Our goal is to build a system within our current urban system. On the one hand, we want to help the people in need to mitigate the heat island effect. On the other, we also believe that in the process, the system can empower them as an important community. Thank you for listening.
Yeah, thank you, Group 302A, for the very thorough analysis about the issue. Now let's welcome Group 302B, led by Professor Chen and Professor Huang, to share their findings.
Okay. Hi everyone. Today, okay. And the issue we're going to talk about is building urban heat island, how to face the challenge of the increasing cooling demand. And to face the UHI, we have some response which is from passive design to active building, making the city breathe. But how to do it, that's what we're trying to figure out today. And in response to this issue, we found a practical base to operate, using the park as a cold spot and center point in the city to explore the 500-meter area around it. And first, we roughly divide the building forms around the base into 20 types, for example, like this, different types. And then we and propose strategies to improve the heat island effect for individual buildings of different forms. Then we connect the single buildings into neighborhoods, enlarge the perspective to the neighborhood scale, and apply environmental characteristics to make adjustment according to the relative relationship, environment, and orientation of the buildings. Next, we will enlarge the scale from the neighborhood to the city and integrate the neighborhoods. We can find that these strategies create an airflow in this area and achieve the heat dissipation effect through the airflow, thereby improving the urban heat island effect. So to sum up, we start from the challenge of how to improve the urban heat island effect and take a site as an example, try to connect the dotted buildings to the linear neighborhoods, and then enlarge to the planar city from small scale to green the way of architecture to think about the large scale planning direction. And based on the result of the above discussion, when planning urban projects in the future, in addition to functionality, whether such environmental factors as ventilation, hot and cold convection, green and water, and sunlight can be used as planning principles is important to be considered. And thank you for attention.
Thank you, Group 302B, for your presentation. And now let's welcome the last group, 301A, led by Professor Wu, to share their findings.
Hello, everyone. Hello, everyone. I'm the team member from Professor Wu. And first, we list some vital elements about the urban heat island effect. For example, like green zone, blue zone in the city, and humidity and temperature, and sun angle and the height of the building. And imagine that you walk in the city and you want to know the weather information nearby. But there are many information separated in different, for example, like websites or your for app or something else. So we present a weather information. And our proposal is to put a lot of weather information into a citizen weather station. And the higher high level was use the satellites to provide the information, for example, like the green zone or blue zone. And the medium high level information is acquired by the many drones in the city. And the lower high level information is acquired by, for example, like U-bike or sharing motorcycle system, like Wemo or something else. So there are many information to provide to a citizen weather station, and you are a user working in a city, so you can just download an app and you can know a lot of information surrounding you. And this is our proposal. Thanks, everyone.
Yeah, thank you each group for their presentation, and we really appreciate your sharing. Now it's time for the closing ceremony. Closing ceremony will be started in a couple seconds.